Shut your mouth with your blah blah blah. Zip your lip like a padlock. Meet me in the back with the jack, the jukebox. Care where you live at. Just turn around, boy, let me hit that. Don't be a little bitch with your chit chat. Just show me where your dick is. Listen high.
Hello, welcome to Wacky Math Facts. I'm here to teach you some wacky math facts. Hence the wacky math facts. I'm Dr. Triangle and I'm here to teach you the 5-3 vocab. First vocab word, orthocenter of the triangle, the point of concurrency of the three altitudes of a triangle. That point there, where they meet, is the orthocenter. Median of a triangle. A median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. That line there is the median. The centroid of the triangle. The point of concurrency of the medians of a triangle is the centroid of the triangle. That middle point there is the centroid. Altitude of a triangle. An altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. As you can see in the book, that line there is, these three lines, the red ones, are the altitudes. That one there is an altitude because it forms 90-degree angle with this one. Same with that one, and that one forms 9 degrees down. And this one just helps form the orthocenter, which is also part of the altitudes. Okay, thank you for listening to the vocab for 5-3.
This is theorem 531, the centroid theorem. The centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint on the opposite side. So AP would be 2/3 the distance of AY, and BP would be 2/3 the distance of BZ, and CP would be 2/3 the distance of CX. So in theory, these sides would be congruent, those sides would be congruent, and then those sides would be congruent due to the centroid theorem. Okay, now we're going to use the centroid theorem to find segment lengths. Okay, in triangle ABC, AF equals 9 and GE equals 2.4. Okay, now we have to use the centroid theorem to find AG. AG equals 2/3 over, no, AF, 2/3 AF. AG equals 2/3 times 9 because remember AF equals 9. So all together AG equals 6 because 2/3 times 9 equals 6. Now we have to find line CE using the centroid theorem. So we do CG equals 2/3 times CE. So CG plus GE equals CE. And 2/3 CE plus GE equals CE. Now we have GE equals 1/3 CE. And GE, remember, is 2.4. GE equals 2.4 equals 1/3 CE. So now we have 7.2 equals CE. And that's that for example 1.
Okay, for example 2, we've got that nice little graph right there. What we have to do, the diagram shows the plan for a triangular piece of a mobile. Where should the sculptor attach the support so that the triangle is balanced? We're going to use 3 steps to solve this problem. The first step is understand the problem. The answer will be the coordinates of the centroid of triangle PQR. The important information is the location of the vertices. Point P is located at 3, 0. Point Q is located at 0, 8. R is located at 6, 4. Second step of this problem is to make a plan. The centroid of the triangle is the point of intersection of the 3 medians. So write the equations for 2 medians and find their point of intersection. We're going to have to let M be the midpoint of QR and N be the midpoint of QP. We'll have to use the midpoint formula for M to find that is coordinates of 3 and 6. The midpoint of N is coordinates 1.5 and 4. PM is vertical, the equation is x equals 3. Rn is horizontal, its equation is y equals 4. The coordinates of the centroid are s equals 3, 4. That is example 2. Okay, For 5-4, I will do the vocab again. And we're back with Wacky Math Facts again to tell you Wacky Math Facts again. And I'm Dr. Triangle back again. Well, the mid-segment of the triangle is the first vocab and the only one. A mid-segment of a triangle is a segment that joins the midpoint of two sides of the triangle. Those 3 points, X, Y, and Z, are the mid-segments, and the mid-segment triangle is the triangle you see highlighted. And that's all for the vocab.
Theorem 541 is a triangle mid-segment theorem. A mid-segment of a triangle is parallel to a side of a triangle, and its length is half the length of that side. So here DE is parallel to AC, and DE equals half the length of AC, which would make A and D congruent and E and C congruent, and that is the triangle mid-segment theorem.
And now I will take you on example 1. In triangle GHJ, show the mid-segment KL is parallel to GJ, and that KL is 1/2 GJ. We're going to use 3 steps once again to solve this problem. We're going to have to find the coordinates of K and L. So we'll have to use the midpoint formula to find that the midpoint of GH is -6, 2. The midpoint of HJ is -2, 4. For step 2, we're going to have to compare the slopes of KL and GJ. The slope of KL is 1/2. The slope of GJ is 1/2 as well. Since the slopes are the same, KL and GJ are parallel. For step 3, we're going to have to compare the lengths of KL and GJ. We'll have to use the distance formula and find that 2 times the square root of 5, is equal to KL. GJ is 4 times the square root of 5. Since 2 times the square root of 5 equals 1/2, 4 times the square root of 5, KL equals 1/2 GJ. That is the answer to example 1.
Okay, so I'm going to do example 2 and using the triangle mid-segment theorem. Okay, now we have to find each measure. UW equals 1/2 ST. UW equals 1/2 times 7.4 because the line ST is 7.4. So UW ends up equaling 3.7. Now we have to find the measure of angle SVU, this little triangle right here. So the line UW is parallel to ST, and the measure of angle SVU equals the measure of angle VUW. So saying that the measure of angle SVU equals 41 degrees. And that's it. Go back to the answer.
Say bye. Bye.
I'm Dr. Schnauzenberger. Good day to you. I'm Dr. Triangle, and thank you for not tuning out.
I'm Dr. Vaughn, and this is the Wacky Math Facts.